Hi, my name is Ella Rose Leonelli, and today we're going to be talking about the alternating series test. So, there are a couple of requirements that a series must meet in order to be converging by the alternating series test. The first one is that it must be alternating. The second one is that your b sub n, the limit as n approaches infinity of your b sub n must equal 0, and b sub n must be a decreasing series. If it meets all of those requirements, then we can say that it converges by alternating series test. So let's run through a couple examples really quick. Okay, so the first example we're going to be doing is the summation from n equals 1 to infinity of negative 1 to the n plus 1 all over n. Now the first thing that we're going to do is we're going to identify what our b sub n is. And in this case, we can see that the negative 1 to the n plus 1 is what makes this alternating. So our b sub n is going to be 1 over n. Now, once we've identified our b sub n, we can go ahead and write out the first few terms. This helps us see if our b sub n is decreasing. So our first few terms are 1, 1/2, 1/3, 1/4, and so on and so forth. Now, once we've done that, we can take the limit as n approaches infinity of our b sub n, which in this case is 1 over n. And we can see that the limit as n approaches infinity of 1 over n is in fact 0. Yay! We have proven that this series converges by the alternating series test. Okay, so let's move on to our next example. Our next example is the summation from n equals 1 to infinity of negative 1 to the n squared over n squared plus 5. So the first thing that we're going to do in this situation is we're going to identify what our b sub n is. And we can see that the negative 1 to the n is what makes this alternating, so our b sub n is going to be n squared over n squared plus 5. Now that we've identified our b sub n, let's take the limit. So the limit as n approaches infinity of n squared over n squared plus 5 comes out to be 1. And since 1 is not equal to 0, this is inconclusive because of alternating series test. Because if you remember, it has to meet all three requirements in order to be convergent by the alternating series test. Alright, let's move on to our last example for this video. Now, in this last example, we're going to be dealing with a cosine term. So we're going to say the summation of n equals 2 to infinity of cosine of n pi all over the square root of n. Now, when we're dealing with a cosine or sine term in an alternating series, we should be able to recognize that the cosine of n pi is going to act as our alternator. So we can kind of look at it as the cosine of n pi is equal to our negative 1 to the n or our negative 1 to the n plus 1. So we're able to recognize that our b sub n in this case will be 1 over the square root of n. So let's write it out. b sub n equals 1 over the square root of n. Awesome. Now we're going to take a minute and look at our limit. So the limit as n approaches infinity of 1 over the square root of n, we can see that this approaches 0. So now that we've proven that it is alternating and that the limit does approach 0, let's check to see if it's a decreasing series. So let's write out the first couple terms. b sub n equals 1, 1 over the square root of 2, 1 over the square root of 3, and 1/2. Now we're able to recognize that it has met all three of our requirements in order to converge by alternating series test. So we know that this series converges. So now that we've done a couple examples, let's do a quick overview of what we've learned throughout this video. So what we've learned is that in order for a series to be proven as convergent by the alternating series test, it must meet these three requirements. It must have an alternator, the limit as n approaches infinity of your b sub n must equal 0, and your b sub n must be a decreasing series. We know that if it meets those three requirements, then it will be convergent. We also looked at the fact that a cosine or sine operator will act as your -1 to the n, or your -1 to the n plus 1, or you can just call it your alternator. Thank you guys so much for your time, and these were the sources used for the examples given in this video. I hope you have a great rest of your day.